Hello everyone, I'm Kshitiz Rimal and thank you so much for having me. The topic of our today's session is on-device machine learning. And before we get started, let me share brief about myself. I'm Google Developer Expert on machine learning. I'm also head of research at AI for Development, which is a not-for-profit research organization based in Nepal. And with this organization, we are building deep learning models that can positively impact our society. These models, they fall under categories such as AI for accessibility, AI for disaster relief and response, and so forth. And if you like to contact me, here is my email address, my LinkedIn handle, and my Twitter handle. So let's get started. Here is the overview of our today's session. So first we'll talk about current state of machine learning, then we'll talk about some of its challenges, then we'll talk about on-device machine learning, and we'll deal with creating these on-device machine learning models using a framework called TensorFlow Lite. Then we'll talk about some new improvements in current version of TensorFlow Lite, and we'll finally talk about future directions such as federated learning. Now let's talk about current state of machine learning. So as you can see here on screen, here is some amazing images, and apart from being really nice, they are also generated by an AI, and in particular these images, they are generated by a deep learning model called GAN, which stands for Generative Adversarial Networks. And as you can see, the field of deep learning has progressed so far that they can now create some photorealistic images such as these. And apart from creating these amazing looking images, they can also be used to predict retinal disease progression. They can also be created, to create audios like generated sound waves, music notes, and so forth. And they can also be used to understand protein folding structures and many more. So as you can see, the current state of deep learning has progressed so far that they can do all these amazing activities, all these amazing applications. And interesting thing about all these deep learning models is that they are built using frameworks such as TensorFlow. So let me briefly talk about TensorFlow. TensorFlow is an open source machine learning framework which enables you to build deep learning and machine learning models which can perform activities or applications like I earlier mentioned. And the current version of TensorFlow is TensorFlow 2.2, and it's really easy to get started. So to install TensorFlow, you can easily install it using pip installer. I assume that you are already familiar with pip install command and you are fairly familiar with Python. And one interesting thing about this current version of TensorFlow is that it uses a high-level API called Keras. And with this high-level API Keras, you can easily build deep neural networks. And one of the simple example here on screen is that with this few lines of code, you can easily create a one hidden layer deep neural network using Keras. So as you can see, with just 4 lines of code, you can create an architecture which uses deep learning. You can train your model on this architecture and you can evaluate your model. So as we can see, it's very easy to get started with TensorFlow and Keras, and the deep learning field has progressed so far. So let's talk about some of its challenges. Apart from being like really great at doing all this amazing stuff, there are still some challenges in deep learning, and some of its challenges are these models they can do these amazing applications. They are fairly large in size in terms of GBs, and they are computationally expensive, which requires a user or developer to train these models on server, and which leads to concerns such as privacy and security. As these deep learning models, they reside in server and fairly large in size, we need to pass our data to the server, and which raises the concern of data security and privacy. So to deal with all these challenges, one of the solution is on-device machine learning. So let's talk about on-device machine learning with this one example. So on the screen here, here is an application that I have built in Nepal, which uses on-device machine learning. So this application is called cast recognition for visually impaired, and in Nepal the monitoring nodes, they are not really accessible to visually impaired community. So in order to tackle that problem, what we did is that we built an app which uses deep learning to recognize the handheld these paper currencies that we are holding, and upon recognizing this paper currency, it plays the sound signifying the value of the currency. So as in the screen here, as you can see, you can touch anywhere on the screen of this application and it will capture the image of a person holding this paper currency, and upon recognizing that paper currency, the application will play the sound signifying how much the person is holding. So in this case, here I'm holding 5 rupees note, now I'm holding 100 rupees note, and upon recognizing it says rupee 100 detected. So this is one of the simple example of on-device machine learning, how deep learning models can be used to create an impact. So let's break it down. So from this example, what we can see is that on-device machine learning basically means is that running a machine learning model or deep learning model on device, which means training that particular model or running it for inference. And the device itself is responsible for handling the input, processing, computing, and producing the output. And these devices can be like mobile phone devices, they can be IoT devices like a Raspberry Pi. So this is the fairly simple overview of on-device machine learning. Now, why we need on-device machine learning? Like I said, this on-device machine learning enables us to run this machine learning model on device without having a need to talk to a server or a remote cluster. So that means there is no round trip to a server, which saves a lot of latency. And since the device is responsible for handling the machine learning model, the model itself resides on the device, your data will not go outside of your device, which leads to privacy. So no data needs to leave the device, which leads to privacy, and you can be ensured of that. And connectivity issue. So since these deep learning models, they are on device, there is no requirement of internet connection. So these applications, they can run offline. And since there is no connectivity issue and these network connections, they are very power hungry. So that leads to fewer power consumptions compared to the applications that requires to talk to a server for inference. So all this activity can be done, this on-device machine learning activity can be done using a framework called TensorFlow Lite. So let's talk about TensorFlow Lite. So TensorFlow Lite is a production-ready cross-platform framework for deploying machine learning on devices and embedded devices, which means your device can be an iOS device or Android device or system running ARM architecture. This TensorFlow Lite model can be deployed there, and it will enable you to run this on-device machine learning and deep learning models without having to connect to internet connectivity and so forth. And let's talk about what it can do right now with TensorFlow Lite. So as earlier example, it can perform image classification, and here is another example doing roughly the same. So here in this application, I'm selecting an image, and upon selecting the image, this application is running on-device deep learning model, and it is classifying the selected image based on 1000 categories. So as you can see here, if I select this image, it recognizes that it's a desktop computer, and I can select all these different images from my personal gallery, and it will not send this data to the outside server, and it will run inference on device and do the prediction, this image classification. And apart from performing image classification, it can also do object detection, which means not only classifying whether the object is there in the picture, it can localize the object and draw a bounding box around it. So as you can see here, the model recognizes there's a mouse, there's a cell phone, and it draws this nice bounding box around it to localize it and recognize it. So it can perform object detection as well. And apart from object detection, it can also run semantic segmentation, which means, so if there is a person on the screen in this example, the model can easily separate out the particular person from the image. Apart from just classifying it or drawing a bounding box around it, you can also pixel wise classify certain objects in an image. So in this example, the model can successfully pixel wise classify whether there is a person in the image or not. And on top of that, it can also do pose estimation and hand tracking. So here in this example, the model is running some hand tracking application. It can recognize the different gestures of hand, whether it's a okay, whether there's a 5, so all this different kind of gesture, and you can track the hand, you can estimate the pose and so forth. And it can also be used in NLP, natural language processing examples such as this. So using this TensorFlow Lite model, one can ask the question to the model and it gives you the answer. So in this case, in this example, if the person asks like, of what nationality was Martin, then it will it will give the answer to you, and it will tell you like when he died and so forth. So it's really cool and interesting, and apart from all this example, it can do so much more, like video generation, content text generation, audio synthesis, and all these different examples. And right now, thousands of production apps already use it globally. So the apps that we use every day, like Google Photos, Gboard, YouTube, Airbnb, Uber, they all use some part of TensorFlow Lite in their app, and there are thousands of such apps globally. And apart from these apps, it is estimated that there are 4 billion mobile devices globally that are now have now deployed TensorFlow Lite model in production. So let's talk about creating this TensorFlow Lite model. So in machine learning or in deep learning, general training workflow is like this. So you first get some data, you collect your data, you pre-process them to a certain format that is able to pass to your model. Then in this example, it can be a TF data format or anything you like, and you can then build your model, and then you can pass your data to this model for the training. And for training, you can utilize a distribution strategy, you can evaluate your model using TensorBoard and so forth. And finally, when training is done and when you are okay with your result, you can save your model using a save model format. And this is now the official format for TensorFlow to save your deep learning model. Now, once you train your model using this workflow in a same model format, then you can convert it into a TensorFlow Lite model. And it's really straightforward process. So you pass your same model format to a TensorFlow Lite converter, and it will give you TensorFlow Lite model. So to break it down, TensorFlow Lite has two parts. One is TensorFlow Lite converter and one is TensorFlow Lite interpreter. So in converter, you pass a TensorFlow.keras model or low-level API model, and this can be of SDF5 format or same model format. And this TensorFlow Lite converter will give you the TensorFlow Lite flat buffer file. And upon creating this TensorFlow Lite model, then the TensorFlow Lite interpreter that runs on your device of inference will recognize and load this TensorFlow Lite flat buffer file and do the inference. And this can be done on CPU device, GPU, and any devices that supports TensorFlow Lite. So let's talk about converting this TensorFlow.keras model into TensorFlow Lite model. And as you can see, it's really easy to do that. So you just pass the location, the URL of Keras model, and it will you just call this convert method, and it will convert it into a TensorFlow Lite file. Similarly, using save model format, you can just pass the directory of where this save model is located, and you call the convert, and it will convert into a TensorFlow Lite. Now let's talk about what's new in TensorFlow Lite. So there are new pre-trained models now available in TensorFlow Lite, which means that with the availability of all these different pre-trained model, now you can easily, integrate them into your app and run inference in multiple of applications. So all of these different pre-trained models that are available now are, some of them can do face recognition, some of them can do NLP, like I showed you earlier, the question answering model. It can also do classification, style transfer, segmentation, and so forth. And to see this elongated list, as you can see here, all these different architectures, the deep learning architectures, are now supported in TensorFlow Lite. And apart from all these different pre-trained model and architectures that are supported by TensorFlow Lite, it is now even improved in terms of latency and performance. So as you can see here on the screen, the TensorFlow Lite that was used during Google I/O 2019, and the TensorFlow Lite version that is used in TensorFlow Dev Summit 2020, as you can see, the same deep learning architecture, this MobileNet V1 architecture, as you can see here, the latency is significantly low compared to that one in Google I/O 2019. As you can see, if the model is this floating point model and that is running on CPU, here is this latency comparison between these two different versions of TensorFlow Lite. As you can see, the latency, the performance is significantly improving compared to the one last year. And to get a better idea, the same model, this model MobileNet V1 model, which is running on Pixel 4 device with single threaded CPU, and this model is now, if this model is a floating point value model, then if it runs on CPU device, then the inference time is 37 milliseconds. Similarly, if this model is quantized fixed point and it runs on the same CPU, the performance will be 13 milliseconds. And similarly in GPU, it's 5 milliseconds. And as you can see here in TPU, these edge TPU devices, which I'll talk very shortly, the performance, the inference time is just 2 milliseconds. As you can see, the significant improvement in performance in this current version of TensorFlow Lite. Now, to get this performance, to get this level of performance with TensorFlow Lite, it utilizes multitude of features and techniques. Some of them are quantization, some of them uses pruning, some of them also can be leveraged using this hardware accelerator that I'll talk very shortly, and they can use a mobile optimized model architecture such as MobileNet. And with this new version of TensorFlow Lite, the developer can also utilize per-op profiling features. And apart from all this performance enhancement techniques and new addition of pre-trained model, the TensorFlow Lite now can be run on all these different languages as well. So if you are an iOS developer, you can use TensorFlow Lite using Swift or Objective-C. And if you are a game developer who uses C# in Unity, you can also use TensorFlow Lite there. And similarly, with this new addition, you can use TensorFlow Lite on Rust, Go, and even Flutter, which enables you to develop this cross-platform native application, mobile applications. Now, apart from all this great advancement, let's talk briefly about microcontrollers. Now, TensorFlow Lite can also be, run on microcontrollers. So, what are these microcontrollers? It is estimated that these microcontrollers, there are around 250 billion microcontrollers all around us globally today. So, let's talk about first what these microcontrollers are. So these microcontrollers, or MCU in short, they are very tiny small computing devices. They don't have any operating system, they have only tens of KB of RAM, they only have CPU and memory and IO peripherals, and they exist all around us. And one of the finest example of this MCU is Arduino device. So if you are already familiar with Arduino, then you can see that this Arduino board, this is an example of MCU, and in particular this board is called Arduino Nano 33BLE, and they have all these different features, such as it has a gyroscope, accelerometer, it has this digital microphone that can be used to record sound. And interestingly, now with this new version of TensorFlow Lite, you can actually run your TensorFlow Lite model on these small tiny devices. So one of the example in running this TensorFlow Lite model on these devices is this. So here, as you can see here, the person is holding this Nano BLE board, and it's doing some hand gesture, and the model that is running on this device, this TensorFlow Lite model on this device, is recognizing whether the person is punching or doing this flex action recognition, and apart from recognizing the action, it can also do speech recognition. So on the right here, as you can see, if a person speaks yes keyword, then the green light will light up, and if the person says no, the red will light up. So even in this tiny devices, TensorFlow Lite can be run. So it can be run to recognize gesture, speech recognition, which is really cool and powerful as well. And here is another example. It uses this touch screen device to recognize the handwritten digit using this on-device machine learning on these edge devices. And one of the new example of this edge devices is this Spark Fun Edge, which has all these different sensors that you can play with. And if you deploy your TensorFlow Lite model, you can do a lot of amazing things, such as speech recognition. And apart from all these devices, Google has its own devices as well. So here is this Coral Dev board, which is a bit powerful than the MCU devices, and in fact it is powerful than Raspberry Pi as well. And it has its own TPU, which is called sGPU, which is Tensor Processing Unit. This enables you to fast, run inference this TensorFlow Lite models on these devices, this Coral Dev board devices. And if you already have a Raspberry Pi, you can utilize this Coral accelerator devices, connect with it, and you can run these deep learning models faster than existing speed in Raspberry Pi. Now, as you can see here on screen, the progression of TensorFlow Lite framework development, and from 2017 to 2020, you can see a lot of new features has been added, a lot of new examples has been added. Like now by the first quarter of 2020, you can see that there is a support for LSTM and RNN, control flow support for training, and neural network API support, and more end-to-end examples. And so you can see that by 2020 we have this so many new features that has added compared to the earlier versions. Now let's talk about future directions, and more specifically, let's talk about federated learning. And in this TensorFlow ecosystem, federated learning is supported by TensorFlow Federated, which is a machine learning technique on decentralized data. So I will really, in a brief, go to this federated learning technique, and since this federated learning is a topic in itself, I won't go in much detail, but I'll just briefly touch upon, since it touches on device machine learning, and it sets out some of the future directions for what could be the future scenarios for on device machine learning. So in a simplest form, federated learning means that in this picture, as you can see, there are a lot of devices, and in each of these devices there is on-device machine learning. And what they do is that they train their machine learning model on device with their own private data. And since security and privacy is the biggest issue here, so what it is doing in federated learning is that each devices, they train their model on their own with on-device machine learning technique. And once they train their model, they're on their device with their own private data, which is not accessible to like external server or cluster. These trained models from all of these each devices, they are sent back to this cloud or cluster. And you have to understand here is that the privacy of the data is not compromised, because the cloud or cluster here, they don't have access to the data the machine learning model is trained on. They have only access to the trained machine learning model. So what is going on here is that each device here is training the model with their own private data, and they are only sharing the trained model to this centralized cluster. And this centralized cloud or cluster, they aggregate all these trained models that is sent by this on-device machine learning devices. They aggregate them, and it sends back to all these devices, giving that all of these new devices, all of these individual devices now have access to the learned model that is sent out by all these individual devices. So in general, in on-device machine learning, what is happening is that your device has only access to the model that it trained on in its own data. It doesn't have access to extra intelligence that can be provided to the device from other devices. Now with federated learning, what is happening here is that since there are a lot of devices that are training their model on their own, once they send out the trained model to this cloud cluster, this cloud cluster aggregate all this trained model, and it sends back this trained model to all these individual devices, giving this extra intelligence capability to individual devices without compromising the data privacy and security, meaning that your model will be intelligent more, even if you don't compromise your data that is already in your device. That is in a simplest form, what is doing is that your model can benefit from other devices that they are training the model with their own data. So with federated learning, what is happening is that you apply this on-device machine learning on your device, but in return, once you connect your device to the cloud or cluster, then you get benefited from this extra intelligence that is achieved from other devices without compromising data security and privacy. And to make this process even smooth and efficient, it can be done when your device is in idle mode, meaning that when you are not using another app or services on your device. For example, while you are when your device screen is turned off or it's powering up, when it's charging, then you can imply this federated learning technique so that it can ensure the interactive, the performance and the efficiency of your device without compromising the performance of your device, and at the same time utilizing this power of federated learning. So in a nutshell, how you can imagine federated learning is that in a large scenario, when a lot of this parallel devices, all these individual devices, when they imply on-device machine learning, when they train their model on their own device with their own private data, with federated learning, somehow without compromising their own data and privacy of the data, they can benefit from the intelligence that is attained by each individual devices. This trained model, they are sent to the cluster, they are aggregated, and the cloud is responsible for spreading out, broadcasting this aggregated intelligence from all these individual devices. So in a very brief high-level overview, this is federated learning, and it seems to be the future of on-device machine learning, and I think it's where the whole the system whole this direction is heading now. Now, if you want to learn more about federated learning, you can go to tensorflow.org/federated, where you can find all these tutorials, guides, and even talks and blogs written by engineers from Google, and you can learn more about it. And if you want to learn more about TensorFlow Lite, I think the best way to learn is from tensorflow.org/lite/examples, where there are like end-to-end examples of image classification models that can be run on multiple devices like Android, iOS, and Raspberry Pi. There is the sample code for pose estimation, object detection, and there are many more. And there is also one amazing repo in GitHub called awesome TF Lite where there is sample code, models, and tutorials that you can utilize to build your own application using TensorFlow Lite. And if you want to learn more about running this TensorFlow Lite models on MCU, then you can look for this book called TinyML, where you will learn about you putting your TensorFlow Lite model on Arduino devices and Raspberry Pi and so forth. And if you want to learn more about TensorFlow and its ecosystem, I think the best way to learn is go to YouTube and look for this TensorFlow Developer Summit 2020 playlist, where everything from TensorFlow ecosystem, whether it's Federated Learning or TensorFlow Lite, they are all covered here. I highly recommend you to go there and watch it. And last but not the least, the best resource to learn everything about TensorFlow Lite, go to tensorflow.org/lite, which is the official website of TensorFlow Lite. And that is all for my presentation. Thank you so much for having me, and I hope this session was useful to you and you find the information that I've shared here kind of useful, and hopefully I will see a lot of cool applications from you using TensorFlow Lite and on-device machine learning. Again, thank you so much for having me. I feel honored to be able to present to you, and please stay safe.